Have you ever wished you could go back in time to rectify a mistake or zoom into the future to see the outcome of your actions? Time travel, a concept that has captured our collective imagination, has been a popular theme in science fiction for well over a century. Whether it's Marty McFly zipping around in his DeLorean or the Doctor exploring the universe in the TARDIS, the idea of bending time to our will is undeniably fascinating. Iconic literature like H.G. Wells' The Time Machine and popular movies such as Interstellar and Back to the Future have all played with this tantalizing concept. But is it all just flights of fancy, or could there be a nugget of truth hidden in these fantastic tales? What if these fictional narratives are hinting at a possibility, a reality that we haven't yet fully grasped? What was once purely the realm of fiction is now a subject of serious scientific inquiry. The idea of time travel is not as far-fetched as you might think, thanks to Einstein's theory of relativity. Now let's dive a little deeper into the science behind it all. Albert Einstein, one of the greatest minds of the 20th century, proposed a radical idea. Time and space are not separate entities, but interwoven into a four-dimensional fabric known as space-time. Picture it like a trampoline, if you will. When something with mass, like a bowling ball or a planet, is placed onto this trampoline, it creates a dip or curve. This curvature is what we perceive as gravity. Now, what's really mind-bending is that Einstein suggested that time, like space, can be warped and twisted by mass and velocity. This means that if you could travel near the speed of light or into the vicinity of a massive object, time would slow down for you relative to the rest of the universe. So in effect, you could leap into the future. But what about going back in time? Well, that's where wormholes come into play. These are theoretical passages through space-time that could create shortcuts for long journeys across the universe. Some scientists postulate that if these wormholes are possible, they could potentially allow for travel into the past. Additionally, the weird and wonderful world of quantum mechanics introduces the concept of quantum superposition, where particles can exist in multiple states and places at once until observed. Some interpretations suggest that this could potentially open the door to multiple timelines or alternate realities. However, it's crucial to note that these are all theories. While mathematically plausible, we are yet to find empirical evidence supporting the existence of wormholes or the feasibility of time travel. So, as we journey through the annals of time, from the theoretical to the fantastical, remember this. However, the scientific journey into time travel is not without its paradoxes. And those paradoxes are what we'll explore next. Imagine going back in time and preventing your grandparents from meeting. Would you still exist? This conundrum is known as the grandfather paradox. If you prevent your grandparents from meeting, then neither your parents nor you could be born. But if you're not born, then how could you go back in time in the first place? It's a classic example of the paradoxical nature of time travel. Let's move on to another paradox, the bootstrap paradox. Imagine finding a book of Shakespeare's plays in the present, traveling back to Elizabethan England, and giving the book to Shakespeare before he's written anything. He copies the plays and they become famous. But who actually wrote the plays? These paradoxes challenge our linear understanding of time and causality, and they make the concept of time travel even more intriguing. These paradoxes highlight the complexities and mysteries of time travel. So, can we pack our bags for a journey through time? Well, the answer isn't that simple. Let's dive into the possibilities first. Theoretical physics does allow for time travel. Concepts like wormholes and quantum mechanics suggest that we might be able to bend the fabric of space-time, creating shortcuts through time and space. Imagine being able to step into a portal in the morning and emerge in a different era altogether. But here's the catch: the limitations. The energy required to create a stable wormhole or manipulate space-time is astronomical, far beyond our current capabilities. And then there's the impact on the timeline. If you change something in the past, how does that affect the present? The answers to these questions are still largely unknown, leading to a maze of paradoxes and conundrums. Time travel remains a tantalizing possibility, but for now, it is still largely confined to the realm of science fiction and theoretical physics.